everyone. My name is Chitransh and today I will be explaining about the topic Dynamic Mobile Cloudlet Clustering for Fog Computing. This paper has been selected from IEEE and International Conference on Electronics, Information and Communication. Now, the problem statement. So, despite the fact that mobile devices are becoming more capable in terms of CPU power, memory, and battery life, still they are unable to meet the demands of high resource consuming application. So, in this presentation, we are going to know about fog computing, which is one of the solution for offloading the task of a mobile. However, because of the high deployment cost, the fog server's capability remains limited. But in this research, the author proposes a dynamic mobile cloudlet cluster policy, which is DMCCP, for offloading fog servers using cloudlets as a supplement and hence satisfying the requirements of high resource consuming application in mobiles. Solution. So in this we will understand about cloud computing and fog computing. So here cloud computing plays a remote server role for sharing the massive amount of on-demand services and provides flexible information technology services or resources for different application. Fog computing, also known as mobile edge computing MEC, defined by European Telecommunication Standard Institute ETSI, brings the remote services more closely to the user. Cloudlet, a cluster of mobile devices, has been proposed as a supplement to the cloud for off-roading in recent study. Cloudlets are accessed over a wireless connection by users' equipments. Cloudlets are the collection of computers or mobile devices that supply computational power to other mobile devices in the area. Cloudlets have been proposed in the past to help mobile user with data storage and job processing. In this paper, author propose a dynamic mobile cloudlet cluster policy DMCCP for fog server offloading. In this experimental simulation, author evaluated the performance of the DMCCP. The result shows that our DMCCP can cluster the approximated optimal cloudlets for different resources demand of a task in a short processing time compared to the optimal method. Now, here we will understand the novelty of this. With the use of cloud computing services, we are now able to use the high computing resources application in our mobile devices. By the use of virtual machines, we can use any alternative operating system and can access it locally. Use of fog server as at the edge of the access point enable us to reduce the latency in the services. Use of fog server also enable us to use location awareness services for the real-time demand response application. For dynamic clustering, that is DMCCP, dynamic mobile cloudlet cluster policy for fog server offloading. Use of DMCCP as a supplement in fog computing improves the overall efficiency. MRM, mobile resource monitor, is used in fog server to observe the available resource. Now, DMCCP can cluster the approximated optimal cloudlets for different resource demand of a task in a short processing time. In our work, the weight of the mobile resources is determined by an observation-based heuristic approach. Now, some of the critics we will understand of this regarding this paper. So, although by this process we can improve the computational power of mobile and other application, but the cost of deployment of fog servers are high. It can improve the latency of the services, but only by the adoption of DMCCP as a supplement. Sometimes due to NP hard time complexity, there we can expect some delay in the execution. It may happen. Now, what is the scope of improvement? So here we evaluate the performance of the optimal method and our proposed heuristic method DMCCP under different number of available UEs and tasks. For the experiment, we clustered clouds randomly in fog server for performance comparison with the optimal and DMCCP method. So in this graph, we can see that we compare the ability of each method to find the potential cloudlets under the limited number of available mobile devices. The result shows that the optimal method can find the largest number of potential cloudlets, and our proposed heuristic DMCCP also can find the number of potential cloudlets approximated to the optimal number. The random method show loosey performance compared to other method, which we can see in this graph. And coming to this, according to the result, the performance of the proposed heuristics DMCCP approximately reaches the optimal method. Here, this figure represents how much resource amount is left in a local device after cloudlet clustering. Less the remaining resource amount indicates the higher performance in offloading of the cloudlets. Now, the performance of this suggested heuristic DMCCP approaches the ideal method according to the result. Now, despite the fact that the optimal approach can cluster the best cloudlet for a job, the simulation indicates a long clustering time due to NP-hard complexity. But the proposed heuristic DMCCP, on the other hand, take less than 1 million second to cluster the data, which is almost reaching the optimal method. Now, this is about the schematic diagram what we have for the proposed method. So here we can see that the fog servers are there, which are ultimately connected to the cloud server, and here we can see all the user equipments are connected, and there is a lots of mobile devices are connected, which are using the services offered by the fog server in order to run the high consuming application. And here we can see that the request task is also coming. The mobiles devices are requesting the task from the fog server, and the fog servers are basically present at the edge of the services, and based on the demand, the computational power has been provided by the fog server in order to run the high consuming application. So this is all about the presentation of this paper. Thank you.